Now that we know the basics of chemical formulas, we're ready to look at how they relate to nomenclature. So let's just focus on nomenclature for a minute. Nomenclature means names, and there's different rules for the names based on what type of bond is there. Ionic bonds or covalent bonds. Part of the difference in rules is what we call a group of atoms that are in an ionic bond versus what we call a group of atoms that are in a covalent bond. A group of atoms in an ionic bond are called ionic compounds. A group of atoms in a covalent bond are called covalent molecules. Remember, ionic compounds are metals and nonmetals, while covalent molecules are nonmetals and other nonmetals. An example of an ionic compound would be a bond between sodium and chlorine, a metal and a nonmetal. An example of a covalent molecule would be a bond between carbon and oxygen, a nonmetal and another nonmetal. So we see the bonds between metals and nonmetals. We see the bonds between nonmetals and nonmetals. What are we missing? The bonds between metals and metals are called metallic bonds. For example, if we had a bond between copper and tin, that would be a metallic bond. When a group of metals bond together, we call those metallic alloys. For example, copper and tin bond together to make bronze. You may have seen bronze statues in a museum or in a book. This is a bronze tiger from the Chinese Shang dynasty, making it hundreds, almost 1,000 years old. However, we're not going to be talking about metallic alloys for nomenclature. We're only going to be talking about ionic compounds and covalent molecules. So let's focus in on the ionic compounds and the covalent molecules. There are 3 levels of difficulty here. For ionic compounds, going from formula to name is easy because there are no prefixes. For covalent molecules, going from name to formula and from formula to name is medium because they do use prefixes. For ionic compounds, going from name to formula is hard because we have to balance charges. Let's start with the medium level. Covalent molecules, name to formula, and formula to name. We will need to learn about prefixes. Remember, covalent molecules are between 2 or more nonmetals. And yes, we have to use prefixes. Let's start by going from name to formula. Let's start with the example tetracarbon octahydride. What does that equal? Does any part of that name look familiar? Well, I see the word carbon in there, and I know what that is, but I don't know where to go from there. Now is a good time to talk about prefixes. Prefixes are small parts of words that go before other words. So we've got prefix for the number 1 is mono. The prefix for the number 2 is di. Then we have tri, tetra, penta, hexa, hepta, octa, nona, and deca. You've used these before in your life. For example, you could probably tell me what this is. This is an octopus, which has 8 arms, riding a tricycle, which has 3 wheels. So when I see tetracarbon, I know that carbon is C from the periodic table, and tetra is 4 from my prefixes. So I can write C4 for tetracarbon. Remember, in chemical formulas, subscript numbers after the symbol tell us how many of that atom we have. Let's move on to octahydride. I know octa means 8, and hydride, I don't know what hydride is. If you look at the whole periodic table, you cannot find hydride. So this is another funny part of nomenclature rules. We have hydrogen, and if we take off the back half of that word and add "ide," we have hydride. For covalent molecules and ionic compounds, the second word often ends in IDE instead of its usual spelling on the periodic table. So carbon becomes carbide, nitrogen becomes nitride, oxygen, oxide, and so on. Can you guess how we would change the remaining ones into IDEs? You may have also noticed that these are all nonmetals. The IDE suffix is just for nonmetals in the second word of covalent molecules or ionic compounds. So if I have octahydride, octa means 8, hydride refers to hydrogen, so we use the symbol H8. That is tetracarbon octahydride. Here is the rule for covalent nomenclature. We'll start with a prefix. We don't need mono. Then the first nonmetal, a space, a prefix, and the second nonmetal, but using the IDE version. Let's apply this rule to another example. Dinitrogen trisulfide. So first is a prefix. Di on our prefix table means 2. Then we've got our first nonmetal, which here is nitrogen. So nitrogen uses the symbol N from our periodic table. You will need a periodic table to do all of this practice. If you have one on paper, great. If you don't, you can open one up in another tab or window. Nitrogen uses the symbol N. Di means 2, so we get N2 for dinitrogen. Then we have a space and the prefix tri, which on our table, tri means 3. Then we've got the second nonmetal, the IDE version, sulfide. If we look at our IDE versions, we know that sulfide means sulfur, so we can use S. So S3 is trisulfide. Dinitrogen trisulfide, N2S3. Let's make those tables a little smaller and see if you can figure out tricarbon hexachloride using the rules below. Pause the video if you want to do it yourself first. Otherwise, I'm just going to shut up and you can watch the screen to guide you through the steps. Here's an interesting one. There is no prefix in front of phosphorus, but the rule is we don't need mono for the first word of a covalent molecule. So because it's missing a prefix, we know that will be 1 phosphorus. And no subscript means we have 1 phosphorus. So we don't need a subscript for this one either. So those are 4 examples. Seems pretty easy, right? We just need to have our list of the prefixes, our periodic table, and the list of the IDE versions of the nonmetals. Now let's use the same rules to do things backwards. So we had name to formula. Now we're going to switch to formula to name. The same rules apply. So if I have C7H10, we'll start with prefix. Prefixes are about counting. So we've got a 7. We look to our table and we see 7 is hepta. So we'll start with hepta for 7. Then we move on to our first nonmetal, which in this case C is carbon. So we start with heptacarbon, space, prefix, we need the count, which here is 10. On our table, 10 is deca, so we can start with deca, and then the IDE version of H, which is hydride. So C7H10 is heptacarbon decahydride. I'll walk you through this next example together. Prefix, don't need mono. We have a count of 2. 2 is di. Next, we have our first nonmetal. P is phosphorus, so we have diphosphorus, space, the next prefix, the count is 3. On our table it says the prefix for 3 is tri. So tri, and then the second nonmetal, but the IDE version. O, IDE, is oxide. So P2O3 is diphosphorus trioxide. For N2S2, we'll start with prefix. What is the count of N? Well, there's no number there. So what does that mean? In chemical formulas, no subscript means 1. So there's 1, but we don't need mono for the first nonmetallic prefix. So we'll just leave that blank. The first nonmetal, N, is nitrogen. Space, prefix, 2 is di. Second nonmetal, IDE version, is sulfide. NS2, nitrogen disulfide. Do the last one on your own. How'd you do? Seems simple enough, right? That's it for covalent molecule nomenclature. We now know for covalent molecules how to go from name to formula and from formula to name using prefixes. We're done with that. Click right there to watch the next video for the nomenclature on ionic compounds. If you have any questions, please email me mathew.abbott@mpls.k12.mn.us or send me a text to 612-615-9750. Thanks.